Good morning, grade 11s. Welcome back. We are now going to prove one of your first trig rules for grade 11, and that is the area rule. The question can either be asked to prove an acute case or an obtuse case. We're going to start off first with an acute angled triangle. And the question asks, in any acute angled triangle ABC, prove the area of triangle ABC is equal to a half AB sine C. So what we do here, grade 11s, we start off, and this is important to note, whichever angle is over here, we place at the origin. Is an acute angle triangle, so we move across there and there. Does not matter which letters we use here, so what are we left over with? We need an A and we need a B. Now, if we have a look at the previous video, we saw we need to first do step one, is to first do all the small letters. So across from angle C, we have little c, across from B, we have little b, and across from angle A, we have little a. We need all the coordinates. Obviously, here we C is at the origin, so we have 0 and 0. B has the coordinates of A, and on the x-axis, our y value will be 0. And the most important point will be our polar coordinate, which is the highest vertex of the triangle. We know from now that will be my radius. Now, when I mention radius, this is actually the circle that we are looking at. From the center to the highest vertex is the radius of the circle. So there's my radius, so it is a B. X coordinate belongs with cos. Cos is defined as the x. Cos of angle in standard position. C, and how do we know we're correct? A, B, C, all three letters. And similarly, we have B sine C. And now we are ready to go. If we think of a triangle from grade 10, we know we have area of a triangle ABC is equal to a half base times perpendicular height. Here we have half base. The base, what is my base? Here we're resting on the base of the triangle, which is an A, and perpendicular height. There's my perpendicular height, and we'll see that the perpendicular height is the same as my y value of my polar coordinate, which is B sine C. And there, grade 11s, we have proved my area rule. It is important to note that if C is in standard position, this is the C value over here. So we have A, B, C, all three letters. If, for example, B was in standard position, in other words, at the origin, we would have a half, and what are my other two letters? A, C, sine B. That would be with B in standard position. And lastly, if we had A in standard position, what are my other two letters? It would be a half B, C, sine A. So depending on the question asked over there, this is the angle that we place in standard position. Let's draw that over there. So before we move on to the next one, the obtuse angles, I'd like you to practice that a few times, and that can be asked as in a test as a question. Let's have a look at the area rule proof for an obtuse angle triangle DEF. And let's look carefully at the question. Prove area triangle DF is equal to a half DE sine F. So we saw from the acute case that we need to put F at the origin. Doesn't matter where we do those two letters. So the obtuse angle triangle looks like that. And we are going to put D over there and E over there. So, what is step one? Step one is to label all small letters. So there's little f, there is little e, and across from angle D we have little d. F is D is the highest point, and that will be my polar coordinate, if we remember. And angle F is in the origin, it's in standard position. So let's fill in our coordinates. Angle E would be D and 0. F is at the origin, will be 0 and 0. And our most important one, the polar coordinate, the highest vertex, will be at D. So what do we have there? We have my radius. Now, from the origin to the highest point is where we have my circle. So that would spin around like that. So the polar coordinate is the radius, cos of the angle in standard position, and the radius, sine of the angle in standard position, and there is my polar coordinate. Once we have those three coordinates, and the most important being the polar coordinate, we can then move on and write the area rule. Area of triangle DEF, according to grade 10, is a half base times perpendicular height, which is a half. What is my base? My base is the letter D, and my perpendicular height is the y coordinate. Here's my perpendicular height. The y coordinate of the triangle in polar position is E sine F. And there we have proved the area rule. Easy as that. If angle D was in standard position, if this was a D there, we'd put D in standard position, and it would be a half EF sine D. If E was in standard position, what would we have? We would have a half. What are my other two letters? DF sine E. And we're going to need this in our following proofs. Easy as that.